BMO 2021 British Mathematical Olympiad Round 2, problem number 3. So, the problem is the following. Let ABC be a triangle with AB greater than AC. Its circumcircle is omega, its is gamma, and its incenter is I. Let D be the contact point of the incircle of ABC with BC. Let K be the point on gamma such that the angle AKI is a right angle. Prove that AI and KD meet on gamma. So let's see how we can solve this problem. So we must prove that when AKI is the right angle, then KD and NI meet on this circle gamma. So we can call it gamma. We want to prove in some other way. How? We draw this bisector AI and we consider that it intersects gamma in point M, and now we connect M and D and extend this line until it intersects again at gamma, and we call it K prime. If we prove that A K prime I is the right angle, then we can prove that K prime is K, and we will prove the problem. So let's see, we want to find a K prime I angle. So at first, we know that this angle is BM and this angle is MC, BM over 2 and MC over 2, and as we've drawn AI, this is bisector, so we know M is the midpoint of this arc, so BM equals MC, and we can conclude that these two angles are equal. Now, we can conclude that MB is tangent to the circumcircle of K prime DB. So we can say MB to the power of 2 equals MD times MK prime. Now we know that MB equals MI. You can prove it by writing the angles. You can prove it by writing the angles IBM and BIM, and then you can see that MIB is an isosceles triangle. So we can replace MB with MI. So MI to the power of 2 equals MD times MK prime. So we can conclude that MI is tangent to the circumcircle of K prime ID. So now we wanna find a K prime I. This angle we want to find it now. A K prime I equals A K prime B plus B K prime I. Okay, we know that A K prime B equals this arc over 2, so it's equals C plus B K prime I. And the bk prime I, now we want to solve it. We know that bk prime I equals bk prime D, as we've written here, minus ak prime D. So we must find these two angles. So bk prime D equals bk prime M. This is equal to the half of this arc, and you can write it A over 2. So we must find minus AK prime D, this angle. And now we know that this is equal MID because we proved that MI is tangent to the circumcircle of IK prime D. So we know that IK prime D equals MID. Now we must find this angle, MID. We write C plus A over 2 and we want to find MID. MID equals BID minus BIM, as we've written here. What is BID? We know that this is a right angle and this is B over 2, so BID equals 90 degrees minus 90 degree minus B over 2. So we found this angle. Now we want to find BID and BIM. BIM equals, this is the external angle of this triangle, so it's equal to the sum of these two angles, A over 2 plus B over 2. So we write minus BIM equals minus A over 2 minus B over 2, and now we want to simplify, we can write C plus A over 2 minus. We know that 90 degree is A over A plus B plus C over 2. So A over 2 cancel with this, B over 2 cancel with this, so we have C over 2 minus B over 2. And now if we cancel C with C over 2, we have C over 2, A over 2, and minus minus B over 2 is plus B over 2. So we have A plus B plus C over 2, and it's 90 degree. And we prove that AK prime I is a right angle, so K prime is K. So KD and AI meet on the circumcircle of ABC gamma. We proved the problem.